Welcome, everyone, to this special Spud Smart panel discussion. We are calling it Soil Under Siege. And today we are digging deep into one of the biggest challenges facing potato growers right now. That is the fight for soil health. We've brought together three of the very sharpest minds in potato production for what I am hoping, let me just throw it out to all of you guys, will be a candid and unscripted conversation about what's working, what isn't, and also the questions we still need to be asking. So let me introduce each of you. I'm delighted that we have you here to join us. First up, Dr. Gary Secor. Gary, am I right in saying, let me give you a little bio. You're a plant pathologist with North Dakota State University, and I know you to have decades of experience tracking soil-borne diseases like silver scurf, black dot. You're kind of the go-to guy for that. Am I right in saying that if it's lurking underground, you've probably studied it?
I think that's a good statement, yes. And I've been doing this for 47 years, so I've got all kinds of things that I've looked at over the years.
Excellent. Okay, well, we're going to pick your brain on it. Next, let me introduce Joy Youwakim. Joy, you're a soil biologist who focuses on living networks in the soil and how they influence crop resilience. When we brainstormed about hosting this panel, you were very top of the list of invitees because I see you as bringing a really important element to this conversation, talking about beneficial microbes, soil biology. So thank you for making time for us. And finally, Chad. Chad is Dr. Chad Hutchinson. Chad is Global Director of Potato Research and Market Support for TriCal Group. You, Chad, I see you as sort of working at the intersection between fumigation, agronomy, and soil health, market-driven sustainability. It's kind of that whole combination. So I also know that you have a ton of real-world experience at various events that we've been at. I have picked your brain on so many different topics. So delighted to have you here as well. Should we jump into the good stuff here? Gary, can I start with you, and let's talk about the big baddie, which is black dot. Black dot is getting a lot more attention lately. So tell me what's changing in terms of spread, severity, grower awareness?
You know, one of the things that's interesting is I like to talk about the big four of soil-borne pathogens: verticillium, early dying, powdery scab, black dot, and common scab. And the one that is really becoming more important in recent years is black dot. And I think it's becoming more important because most of the varieties don't have resistance. We're having problems finding enough land to do crop rotation, and this organism stays in the soil for really long periods of time. And we don't really have a management strategy for that in the past years. But it's becoming more important now as blemish becomes more important and as yields become more important, as economics become more important. So black dot has been emerging for 40 years, but now has really become important mostly in recent years.
So Chad, you talk to a lot of growers. What are you hearing about how concerned growers are with black dot?
I think you mentioned it in your question to Gary, Madeline, in that it's a disease that growers are becoming more aware of, right? And it's something that they're seeing more of in their field. They're not just thinking their early die is a verticillium issue. They're becoming more educated and understanding all the players and the roles they have in that early die complex. And as Gary was alluding to, black dot plays a significant role there. So they're becoming aware that it is a yield stealer. It exists underground, and once you know you have it, there's not much you can do about it. And so they're looking for answers. And I can tell you that our strike cells have been moving more towards black dot suppression in a lot of farms globally. And so growers are understanding that there is a tool that could help.
Yeah, and one of the key points you made, Chad, was that there's not very many management tools or strategies or tactics for black dot. So they're pretty desperate to find something to get.
So let me throw a question to you, Joy, which is you're an expert on soil life. How much could or maybe do beneficial soil organisms play sort of a role in mitigating black dot?
They can play a big role. The microbial ecology is very dynamic and changing. You'll have a different ecology when you're before you plant, when you are planting, when the crop is in different key phases of maturity. So we have new technologies now when we're talking about sequencing or DNA sequencing soil to model that ecology and see who the key players are at these moments in a field. There will be some like really common threads just as a potato microbiome is, but there are also going to be really unique differences based on soil type, management practices, etc. And when it comes specifically to diseases and even more specifically black dot, there's really interesting research that looks at different species of Bacillus, Pseudomonas, Trichoderma, and the specific species within those genera that can act as biocontrol so they can antagonize the microbe that causes black dot. I would say a lot of that work is still very novel, and they're looking at those species that have been successful in other similar fungal diseases and other crops, but that is where the work is now. But they're absolutely our friend. Like microbes are a tool in our arsenal, and they can be used for good once we understand which specific ones can be successful and what environment they need to be successful, and then what we need to do to create that environment.
Right. So can we broaden that discussion a little bit with what would be the microbial indicators of healthy soil versus a field where soil health is really struggling?
We look for microbes that can, and I would say that's a really, even general question. There are going to be people that are looking for specific players. So you can look for microbes that help produce stress adaptation hormones, that have natural biocontrol, that have generally great nutrient cyclers. You want all those things to be good, but if there's one goal that people, or a risk that people know that they're heading into in the season, then they can look for those. But I would say in general, if you're looking to judge and say like this field needs a lot of TLC or this field is doing well, you're looking at metrics like overall functionality, overall biodiversity. Are we seeing a lot of different microbes? Even if we're not seeing a lot of different microbes, the microbes that we do see, do they have a lot of different functions? The keywords here are cooperation, synergy. It's not like a quantity over quality situation, but you want to know that there's a nice balance of biodiversity, functionality, microbes that can provide resilience, resilience characteristics. So that's what I would say.
Do you feel like growers are already recognizing the value of it, but that value is just going to grow and grow and grow?
You
go, Joy.
I would say it's positive and negative. I would say, yes, we are at the very beginning of the science. This is novel science, and not the sequencing itself, but sequencing of soil, modeling those interactions, and making, providing information that lets growers take actionable results from that is all new. Like we're talking the last 10 years, and it will only get better. I do think that growers are really into it, and soil biology has been the long neglected sibling when you're talking about soil chemistry and soil physics, because we didn't have the tools to really understand it. There are lots of tests that give you general information about soil biology, but even today with our very specific sequencing, there's a lot of questions left unanswered. But we know that you can't just keep applying the same chemistry and hoping that things go according to plan. We're seeing that that's not working. We need a more holistic approach to soil management, and that means understanding what's going on at a more like living micro level. So that's it's important. I myself feel a stress that we are behind, and because we are faced with with so many increasing challenges, whether it's weather or increase in disease, and just global management of our stewardship. So the faster that the science can catch up and we can provide actionable insights based on what we find, the better. But it's definitely, what we need to be doing moving forward.
When I started here at NDSU, there were a lot of soil microbiology professors, not only here, but around the U.S. And those all disappeared. Those positions never got replaced when they retired. Now soil microbiology is coming back in full strength again with lots of new tools and lots of new identification and lots of ways to identify organisms and compounds that can attack and reduce and manage pathogens. So we've kind of reinvented soil microbiology again with all the technology we have. So that's a really good thing for just studying soil health in general.
But with more of a focus on integration, right? Now, so that there's an idea that the tools have to align with the soil microbiology.
Sure, you can pick and choose. You can also accelerate or destroy. Accelerate the good ones, get rid of the bad ones.
Yeah, I think there are tools in the toolbox that we have. Some are quite old, some are relatively new, and we should not prejudice something for being old. Something may still be useful, right? Crop rotation. It's probably one of the oldest cultural practices we have in agriculture. And I think there's a growing understanding of the importance of that and how it plays a huge role in disease pressure over time.
Yeah. Cover crops is part of that too, Chad.
Mm-hmm, exactly.
Cover crops to encourage certain organisms.
Okay, so I liked your wording there, Chad, of tools in the toolbox. So let me throw that back to the black dot discussion. What tools do we have in the black dot mitigation toolbox, and how confident are we in them? Gary, can I throw that to you?
Well, here's what I know does not work for black dot. Crop rotation is difficult because they stay in the soil a long time. Vapam fumigation is not very effective. Seed treatment compounds don't work very well. We don't have resistant varieties. We don't have any post-harvest fungicides. So we're looking at managing the soil where the black dot organism lives. And there's been a lot of farmer field studies to show that chloropicrin, for instance, can not only reduce the amount of disease, but also reduce the number of organisms in the soil. And I have a colleague named Julie Pashy who's doing some work looking at soil population. She's got a graduate student, and she finds that chloropicrin will lower soil cholototrica populations and also reduce the amount of disease. So to me, that's really encouraging if we can substantiate what growers see in the field.
Okay, so now your comment there is a really important one if you're going towards the fumigation discussion, which is I can't remember exactly what your wording was, but along the lines of manages the organisms in the soil. So Chad, let me throw it to you. You are an expert in fumigation. We all know fumigation is a very powerful tool, but it's also a bit of a lightning rod in the sustainability conversation. I know that there's a lot of people who think fumigation is fumigation. You go in, it's going to manage the bad, but it's going to make Joy awfully unhappy because it's going to also take out all of the good. What's your response to that?
Yeah, we're in this age now where sustainability is becoming more talked about. Regenerative agriculture is being discussed more. We all want to move in a more sustainable, both environmentally sustainable and economically sustainable direction, right? We want our farms to stay healthy and profitable, our farmers, our communities, farming communities. And, the longer I'm in agriculture, the more I wish I would have been a plant pathologist. I always tell Gary, I wish I had been his graduate student, but
yeah, you still can.
But soil-borne disease is a challenge to the industry, right? To the potato industry in particular. There are so many soil-borne diseases that we don't have good suppression options for that impact yield. And if we want to improve sustainability globally, we need to increase production per unit area, per acre or hectare. That's how we become more sustainable, because we want to farm the land that's already being farmed. We don't want to go take more prairie or forest or any other kind of native land out of whatever it's doing now and bring it into farming. We want to do a better job of farming what we have. And to do that, we need to suppress soil-borne disease. And I think a product like chloropicrin is a good first step. It's not the only step. And if you use a product like chloropicrin, it doesn't mean you forget everything else, right? You still need crop rotations to build microbial communities and build organic matter. You still need seed development to have some resistance. You still all need all those other things. It's just bringing them all together to maximize the benefit of each. And to your direct point, chloropicrin is a lightning rod. Fumigation is a lightning rod. Again, the more I'm working in this industry, the more I see that it shouldn't be. It has a lot of benefits that it brings to farms, but it doesn't sterilize the soil. In fact, it actually promotes the beneficial organisms that Joy was just mentioning. And I know as a company, the TriCal Group has spent a lot of time and effort trying to document and figure out exactly what this product does when you put it in the ground. And what we're seeing is very positive. And to have a product put in the back corner just because of the type of product it is unfortunate, because as a society, we need to find all these good tools to move forward and make progress.
Okay, so Gary, you mentioned at the front end of this part of our discussion that there has been some farmer work around this and some good results coming out of farmer fields, suggesting that, am I right in saying that the soil biology is being benefited by chloropicrin?
Well, it appears that the disease is being reduced and they're getting better yields. So I'm assuming that it's changing the microflora in the soil, getting rid of the bad ones and probably promoting the good ones. So that's one of the things we need to do, like Joy does, is to continue to look at assaying the soil and the organisms that are increasing and the organisms that are decreasing, and saying, oh yeah, these are beneficial, these are detrimental. So that it leads us to the observation needs to be proven, if you will, or verified or validated, whatever the word you want to use.
Moving beyond assume. I like it. Okay. So Joy or Chad, thoughts on this? Any sort of backing up evidence?
Tell you what I've seen. I've looked at thousands of chloropicrin samples in soil, and specifically with potato. There's different, we sample a control. We sample before the product goes in the ground. We sample a control at every time point, so that there's a comparison of untreated soil to chloropicrin. Chloropicrin it only goes in the ground once. We wait until it decomposes and then plants go in. So we sample at all these time points, and what we see on average is not this complete, all right, everything's gone. We do see some populations decrease, some populations increase. We see typically around the third time point that we sample, so maybe 45 days after the application of chlorpyrifin to 60 days, that these biocontrol agents or these saprophytes really increase in population. So that's interesting. We have theories to that we're working on sussing out. Maybe from the microbes that did die, we're having these other microbes grow to eat them. And I'll say also, we see these fluctuations and changes in population with other management practices as well. If you're talking about tillage, if you're talking about the application of other products, any wave that you put in or any drop you put in is going to make waves. So we're observing those waves, and they're different. They're different based on the different rates of chlorpyrifin used, based on different soil types, based on other management practices of the farm. This work is not linear at all, but from all of the different work that I've looked at, I can confidently say that we're not just losing everything when you apply chlorpyrifin. You are seeing a wave come in and shift the microbial ecology, and that shift is not consistent in every sample that I've seen. It's not predictable. Except that the trend of 45 to 60 days later, we see an increase in biocontrol agents, natural biocontrol agents. And they're not the same ones every time. There's like 10 that I monitor for, and in some samples or in some trials where we're looking at a full potato cycle, we'll see 3 of the 10. And in another trial, we won't see those 3 at all, and we'll see a different 3. So it's really at the precipice of this work and understanding these plant microbe interactions and microbe to microbe interactions based on land history. That's another thing, for growers that are listening and farmers that are listening, you're the one that knows your field the best. So the more detailed records that you keep, the more information that we have is the more information that I can give when I am digesting this information to help shape the narrative for both parties. So we're a team. And all of the different roles that we have, we're very much a team, and we need each other because we don't know what we don't know.
For sure. It's a real challenge for a grower to be able to tease apart, especially where the science hasn't caught up entirely to the point that there are strong recommendations. It's hard for the grower to tease apart exactly how they should take this information and then execute in their own field. So when we're talking about black dot, can I throw maybe the toughest question to each of you? What's your recommendation? What do you suggest growers do?
So I can start with an answer that the one I think is with the technology that we have, we need to be able to do a soil assay of a field to look at the population of, say, the black dot pathogen in that field. And then we need to say, okay, what's the threshold where treatment increases profitability for that field? What's the threshold that we should use to treat or not treat? And that would be a really good beneficial thing in the future that needs to be developed for a field to help a grower make a decision. Treat, not treat.
Okay, and by treat, you're meaning specifically fumigation with chlorpyrifin, or
yeah,
that's
sure.
treatment.
As an example, that's all we have now, really.
That is the one and only tool that seems to. Yeah. Okay.
Right. Exactly.
Just add a bit more to that. I think Gary covered it well. We need the economics behind treating or not treating, right? Understanding that based on population. It's a horrible disease because it not only attacks roots and destroys those, it clogs up the stem and prevents movement of phloem and water in the stem. And it also affects the daughter tubers with a blemish that can make marketable tubers unmarketable, right? So it affects pretty much all parts of the plant. I just learned from Gary the other day, it even has leaf symptoms I didn't know about. So it's a real challenge for the industry to get a hold of this organism. So As Gary mentioned, I think there is right now only one option. Doesn't mean there won't be more in the future, but right now you're looking at use of chloropicrin at an appropriate rate based on soil type and other things that come into consideration, and working in that direction, making the best of that application.
I would say it's initially important, do your scouting, do your initial soil samples and see what you're dealing with. If there is a different, and I won't contradict, what Gary and Chad are saying around chlorpicrin being effective against it. But it's not I don't want people to feel like it's the only option, especially if they can't afford it. There are lots of different experiments that you can do with looking at different biostimulants that have biocontrol. The few that I mentioned at the beginning that have been shown to be productive against antifungal, or as antifungals, like against fungal diseases, could be interesting to look at. It's research that I do now, looking at fumigants and also combining them with biostimulants. So this is, I want people to feel hopeful that there are solutions out there, and it'll just take time for us observing what works the best and what sort of synergies work well.
I've got one comment I want to make. I like this team of three people that we've got on this discussion, because my job is to find out what causes the problem. Chad's job is to find out how to solve the problem. And Joy's job is to explain why it worked. So that's a really good approach to disease management, and especially for black dot.
Absolutely. I needed you to do the introductions at the front end, Gary, instead of me. That summarized it exactly perfectly. Listen, you guys, I really appreciate you making the time. This is it's certainly not the first conversation on black dot, and I for sure know it will not be the last one. But I think it's an important one. People really want to be hearing more about the disease and how to manage it. Thank you all for making time. I think that this is a great entry point to an important conversation here. Any last thoughts that you just want to get in there in a sentence or two before we let you go?
I would say, I would just reiterate, it's so important to keep records. It's very easy to feel overwhelmed. You've worked so hard, you've planted your field, you see some disease. It's really important to quantify what you're seeing, especially over time, areas of the field, how much, and that can help make it more manageable when we're talking about solutions, and also give information to the different people that are trying to help. So we say, okay, these are the patterns that we're seeing. These are the management practices that were taken. What can we do next?
Excellent advice.
And I would just say change is good, right? You don't have to be stuck in a repetitive program. Do research on your own farm. Look for people that can help provide solutions and answers. Dr. Secor is an amazing resource, right? And as far as I know, he's never said no to a grower, I'm pretty sure. So reach out, involve people, and get help if you need it.
Yeah, and I love doing that. So you know that. Yeah.
We're all here to help.
Love it. Last thoughts from you, Gary?
Well, I just want to say thanks for giving me an opportunity to participate. And it's been most enjoyable, and I'll look forward to helping as I can.
Well, guess what? I'll bring you back and let's have another conversation.